Good day, doctor. My name is Derrick HENG with matrix number 287707, and now I'm going to present about my sensor-based project, which is Intelligent Environmental Monitoring System. So now I will introduce about the hardware component I use in this project. The first one is a light sensor, which is a TEM6000 module. It measures light intensity in analog form. The second one is MQ135, which is a gas sensor. It measures gas concentration for various types of gas. The third one is accelerometer, which is NPU6050 module. It measures the acceleration and rotation across all axes. The fourth one is BME280, which measures relative humidity, temperature, pressure. And there's also two variable resistors. It used to control the input voltage to ESP32. And ESP32 only accepts 3.3 volt, but MQ135 output 5 volt. So this is my output application, which is a Wi-Fi relay. On top of this is a SKIJ3113. So now go to the software part. Initially, we need to start a serial monitor. When serial monitor is ready, it will check for no configuration in memory. If no configuration is found, it will open a web server to upload configuration, and the web server can be accessed by using this access point. The access point have the SSID of sensor project and no password required. So for now, we need to connect to the network first. After we connect to the sensor project network, we can use the IP address to access the web server. And when we access the web server, it will scan for nearby network. So let's input a correct password and click submit. You say form submitted. If the SSID and password is correct, it will generate a token for us. We need to save it somewhere because it's only generated once upon config. So after we copy, we can click cross, it will cross out the website. If we go back to the serial monitor, as you can see, it has restarted and read the network configuration for memory. And if it's valid, it will authenticate a token with the backend and begin to sample the sensor data. At the backend, I actually implement machine learning model for anomaly detection in the sensor data. The algorithm I use is one-class SVM, which is known for novelty detection. So the sensor data I separated to three categories, which is environment, consists of these four features: temperature, pressure, humidity, gas concentration. Light as itself is a model because light is quite constantly changing, and vibration is itself a model, and these three models each have their own sensitivity. And if we run the backend server now, it will start to connect to the MQTT server and subscribe to the ESP32 topics and receive their sensor data. Initially, it will load the model. When the new data comes, it will detect whether it's anomaly or not. And if it is not anomaly, it will save the data after the fifth one to conserve memory. But if it is an anomaly, for example, I now make vibration. As we can see, the anomaly is detected, and this data is immediately stored to the database, and warning email will also send to the specified recipient. So if I go to my email round and refresh, I am going to see the email notification. 0 minutes ago. Here we can see environment anomaly, vibration anomaly true. So the full data is also sent to my email. So if we go to the database, we also see the entry is being added at the same time. Now we have successfully rebuilt the new model. Let's try out the new model effect. Let's take the light sensor, point it towards the red LED of the MQ135 to see what happens. As we can see, the relay switch on. Then if we head over to my email, you can see that there is a new email 0 minutes ago with the information. initially to the front end. When we access the front end, it will redirect us to the authentication page if no valid token in the local storage, and if we input the invalid token, it will send the token to backend for validate and tell us invalid token. If we lost the token or token malfunction, we can configure the MCU to obtain new token. So if I paste the valid token here and click submit, we will be able to access the data dashboard. See all the data in category is here, and there's more advanced controls such as viewing different types of data, view the data as table, then as well as full screen viewing of data, and export the data to various types such as CSV. And we can see the data is dynamically updated at the front end using WebSocket in real time. You see the change in the rate, and there's also more advanced option at here. You can change the normal email notification recipient, for example change to Derrick so only. If you go to the back end, you can see that the recipient is changed to Derrick so only, and here the recipient JSON also one only. But if we undo the change and confirm again and go back to the back end, soon we'll see here that the image at the back. And for data saving, we also can change the data saving rate to something higher for conserved memory. For example 8. To the back end, you can see the data rate is changed to per 8 data saving, so that if no anomaly, it will only save after 8 data. But this setting will be ignored if anomaly data is present. The last also got disable detection. If you click it, it will disable all sorts of detection, including the anomaly detection. So no output device will receive the anomaly notification too, including the email and the Wi-Fi relay. And above is the more advanced setup, which we can choose to rebuild different model and choose the data size. If I select 1000 and click confirm, you start rebuilding. If you go to the back end, you can see it start to build the dataset and will be finished is 70 minutes. And we go to the serial monitor, it also say remaining data 900, and it's sampling at 1 Hz, which is 1 sample per second. So let's wait for it to finish. Now we have successfully rebuilt the new model. Let's try out the new model effect. Let's take the light sensor, point it towards the red LED of your MQ135 to see what happens. As we can see, the relay switch on. Then if we head over to my email, you can see that there is a new email 0 minutes ago with the information. So that's all for my presentation. Thank you for listening.